these things right here that look like bar graphs, just deal with it, audience. If you have a mathematician coming to talk, you're going to get a bar graph, okay? That's showing how the Bible was ahead of its time in every instance. That's really something to see, but it's going to take me a while to do it. I have this on DVD, and you can get that for what I believe is a pretty good price. Which is correct, creation or evolution? We're going to use mathematics to make the determination. Now, comparing creation and evolution, I'm taking both camps' story. And the story that is told in the Bible is that due to the genealogies of Genesis, so was it 5 and 11 and other places, how many years this one was old and had begat this one and begat that one and so on. And those are reliable. Those are written down for a reason. The Jewish people were charged with keeping those records, and they did it. Okay, so we know there was a flood, if that story's true, they claim, 4,500 years ago. The evolutionists are saying, no, man's been around 500,000 years. Which one is right? They can't both be right. You ready? Here we go. At the rate of 2.5 children per family. Now, little kids, don't get scared. That doesn't mean you no. On average. If you have to, that means that 2 parents replace the 2 that passed on, and you have half of a child numerically, to keep the tribe going. Okay. Well, so at that rate, which is a very conservative rate, and the growth rate is 0.466%. That's under 1/2 of 1%. 0.5 is a half, correct? I'll do this. So 0.466 is less than 1/2 of 1% growth rate.
Per generation?
Yes. And our current growth rate in the U.S. is about 1.7%. Third world countries, it's as high as 4.4%. So that's a very conservative growth rate. Okay, just make that note. And that would give us 7.8 billion people if we go back 4,500 years and then come forward with 6 people or 3 fertile couples. That would give rise to that. I can give you the formula so we can look at it after it's done if you want to. On the other hand, the evolutionary community says that, quote, the evolutionary journey to modern humans ends with the appearance about 500,000 years ago. That's 1/2 of a million years ago of Homo sapiens. That's from probably the most popular book in the U.S. on biology, the Raven and Johnson book. And that means that there should be this many people. If that formula, those numbers in that same formula are right, this is how many you should have. 1.66 times 10 to the 1,012th power. Now, honestly, most people don't deal in numbers like that. But I want to show you this. And my wife was a science teacher 25, or almost 20-something years. And so I want to show you this. Okay, actually they're saying we got a 1,000,000-year-old people tooth now, but we'll just stay with 500,000. How big is that number? And she talked me into doing it, to counting 1,012. Wasn't that what I had up there? Okay. So, now, using the Bible's numbers and common sense, how many have that? We do get 7.8 billion people, written as 7.8 times 10 to the 9th. And that little number parked up there on the shoulder of that other number, every time you change it by 1, that just means you've multiplied it by 10. So every 0 multiplies the 0 on its left by 10. So this is how many people we should have if evolution is true. Drum roll. Boom. We should only have 9 zeros. It should be 7.8 times 10 to the 9th power. That's reality. We've got 7.8 billion people on planet Earth. Count them. Get your world census. Count them. That's how many we actually have. So the question is, who gets us there? Does creation get us there? Yes. Yes. Bullseye. Does evolution get us there? That number is so big that it should be cut off like right in here. And did you know how many electrons could be packed into a universe of 16 billion light years, 10 to the 130th power. 130. That's about a line and a half up there, maybe. That's electrons. There's not. It's not like it's just a little bit off. Oh, well, we were off a little. No, you weren't. We don't even have numbers since we got past here. You know, we don't even number them anymore. Say their name, you know, Scastafakillion or something. I don't know. You get the point? You want a slam dunk? That's it. If you don't remember anything else, remember the contrast between these two things. I mean, you know, 7.8 times 10 to the ninth power is reality. That's 7.8 billion. And this right here, when you raise that 10 to that many times, I can't, that's just not it at all. And I thought you might be interested in this. And I got some of this from the Creation Museum in Kentucky. World population growth. Here's the population growth formula. It's not all that complicated. Population is equal to the original population times the letter E, lowercase e, explain that in a minute, raised to the RT power. R is the rate of growth, and T is time in years. The E is an engineering constant of 2.718. Don't have time to explain how that was arrived at, but everybody accepts it. And so here you go. If you put 8 people there, or 6, I should put 6 because of the 3 fertile couples, 6 times 2.718 raised to the rate of growth, 0.466%, move your decimal 2 places now, put those 2 zeros in there. And time, 4,500 years, you know what you get? You get 7.8 billion. Now, if we are growing at 1.1%, what did I say our growth rate was in the U.S. a while ago? Class? 1.7%, right? Uh-huh. I know I'm throwing a lot of numbers out there. Not all of them stick. 1.2%, at 1.1%, we should have 148 million. 1.2%, 759 million. 1.3% should give us 4 billion. 1.4% gives us way more than we have. Look at that tiny little margin. You see? This is pretty fine-tuned. So creation we think was around 6,000 years ago, 4,000 BC, and populations grow exponentially typically. What about roach populations? If you don't do anything about it, they grow exponentially, don't they? What about rabbits with no foxes? They grow, okay. So they grew up, and I got a few arrows here that might be illustrative. Whoops. Okay, so right here, rapid early growth. I don't know how many, but probably close to 1 billion. And then Jesus' birth, how many did we have? I don't know, speculate 500 million. It dropped down, but then it started growing again. It leveled off for a while as it appears, and then it's skyrocketing in recent times. Now, actually, don't worry about it too much. It's starting to flatten out, making somewhat of a sigmoidal curve, as they might call it.